This is a little bit different talk for me from the ones that I've given at this conference in the past, because usually when I come to this conference, I like to give a talk on something that is already there. But this is going to be a talk that is about something that is coming. This is the project that I've been working on for much of the last year. Much of 2023, I spent working on this project, and there's still a few more things that need to be cleaned up, but most of the feature is committed at this point. The main feature got committed to the PostgreSQL master branch in December of last year. So if it's not reverted for any reason, it will appear in PostgreSQL 17, which we expect to come out in September of this year. So you can't use this yet on your production system unless you like running development code on your production system, which I wouldn't do. But I always like to include this disclaimer when I'm talking about work that is not released yet, because things can change. Somebody can find a horrible bug in the feature and the whole thing can get reverted, or somebody can say this thing needs to change or that thing needs to change. So we don't know what will happen. So what I'm going to tell you about today is how things are today, and maybe they will be the same in the future, and maybe they will be different. I think there's a lot of risk for this feature in particular because some of the features that I work on, if they don't do the right thing, well, maybe it will be slow, or maybe you'll get an error. But here, if there's any problem with incremental backup, it will eat your data. Your data will be lost. So this is a very sensitive feature, and I've worked hard on it to try to get all the bugs out, but there are probably still some bugs, and it's going to take some time to find those and fix them. But I think it's an exciting feature, so I'm happy to be able to tell you a little bit about it today. So let's start with what is the basic idea of incremental backup. The basic idea is that we do not want to back up the data which has not changed since the previous backup. And this is going to be particularly important when your database is large. If you have a database of, let's say, 1 terabyte, you probably don't change all of the data in the database every day. Probably most of it stays the same. But hopefully, you do take a backup of the database every day. I hope you do this. Not everyone is doing this, but I hope you do this, just in case there's some problem. But copying all of that data every day can use up a lot of storage space, but more importantly, it can use a lot of time. I've heard a lot of customers complaining, my backup takes 20 hours, my backup takes 40 hours. Well, if it takes 40 hours to do a backup, you cannot actually do a backup every day. And that's sad. Plus, you will almost always be running the backup, even if you are only taking a backup every 2 days, and that's not usually what you want. So, if only 10% of the data is changed each day, maybe we can reduce a 20-hour backup time or a 40-hour backup time to just 2 hours or 4 hours. And that's a huge difference. And I think for most users, that's actually much more important than the storage cost, because storage is becoming very cheap. And if we need to store a lot of data, we can probably do that. For some people, the storage might be an issue, but usually the time is actually the bigger issue. But in order to make this idea work, this incremental backup idea work, we are going to need some way of knowing what data has actually changed. If we want to copy the data which has changed and leave the data which has not changed, we will get it from some earlier backup, then we need some way of knowing what has and has not changed. So I will talk about how we can know this, but first let's talk about what are the requirements for such a system. What do we need to have be true in order for this to work well? Well, the first requirement, and the most important one, is that it has to be accurate. If we think that any data has not changed when really it did, we will not back it up. And then if we ever recover from that backup, our changes will be lost. So that's really bad, right? In the opposite direction, it's not quite so bad. If we think it has changed when really it did not, then our incremental backup will be larger, so it will take more time, but it will still be correct, and we will not have any data loss. So we would like to know exactly what has changed, but if we have some mistake where we think a few things have changed that really haven't, that's okay. It will only make our backup larger. But in the opposite direction, we cannot afford to make any mistakes at all. Now, our second requirement here is that it needs to be efficient, because the biggest reason to use this feature is to make our backups faster. So if it takes hours and hours to determine what data needs to be included in the backup and what data does not need to be included in the backup, then we are losing a lot of the benefit of the feature. So we want our system to be efficient and have a very low effort to find the portions of the database that have changed. Now, another requirement I have is that the system should be easy to implement. Now, that is important for me because I have to do the work, but it's also important for all of you, because the more new code that I have to write in order to implement this feature, the more bugs I'm going to have in that code. All new code is going to have some bugs. You cannot write new code without having some bugs, even if that code is doing something simple, and here we are doing something that is quite complex. So for all of you, it's important that we should reuse as much existing infrastructure as we possibly can so that the number of bugs is minimized. And then a final requirement, which is a requirement for me, but some other PostgreSQL hackers would disagree, is that I don't want to have any reliance on features that are specific to one operating system or another, so that the feature will work the same way on every system, Windows, Linux, BSD, Mac OS, whatever you like, with no differences. I find also that when the features use things that are entirely internal to PostgreSQL, and we don't use things like file timestamps or that kind of stuff, the feature is easier to debug. So when I make mistakes, I can find those mistakes and fix them. So now we can look at how I actually implemented this. I noticed that PostgreSQL's write-ahead log contains all of the information that we need about which blocks within the database have been modified. And what's really good about the write-ahead log, we call it WAL, for this purpose, is that it's already very, very widely used. We use the write-ahead log for crash recovery. We use the write-ahead log for your physical standbys, for streaming replication. We use the write-ahead log for point-in-time recovery. Even for logical replication or logical decoding, we are using the write-ahead log. So if there are any bugs in the write-ahead logging system, they are already affecting lots of other things. And probably there are too many, because since it is so widely used, we would be likely to notice those bugs and find them and get rid of them. So relying on, there's also existing debugging tools like pgwaldump and pgwalinspect, which is also really good in case we have any problem. But there is one major problem with using the WAL that is a big issue for us, which is that it's really big. If you have a busy system, it's going to generate tons and tons of WAL. You cannot even keep all of that WAL stored on your PostgreSQL server where you are taking these backups, because you will fill up the disk. And even if you did have enough storage space there, it would take too much time to read all of that WAL. So we need some way to make it faster. And the way that I did that is we add a new WAL summarizer process, which will read the WAL as it's generated, and it will produce WAL summary files that contains only that information which is required for incremental backup. So everything in the WAL that is only needed for some other purpose, we can leave that out. We take only what we need for the incremental backup, and then we squish that down as small as we possibly can. And in fact, those files are very small, and they are very cheap to generate. So that works actually even better than I thought it was going to. So how can you use this new wall summarization feature? Mainly, you only need to change one configuration setting. There's a new configuration setting called Summarize Wall. The default is off, and in order to use this feature, you need to change that to on. And then you just need to reload the configuration. A full server restart is not required. You only need to reload the configuration. So that's good. There's a second setting that you can optionally adjust, and that is called Wall Summary Keep Time. And this needs to be more than the time between your previous backup and your incremental backup. So if you are taking an incremental backup today, based on some backup that you did yesterday, then Wall Summary Keep Time needs to be more than 1 day. Somebody said, Peter Eisentraut said, well, maybe somebody will want to take an incremental backup today based on some backup that they took last week. So then you would need Wall Summary Keep Time to be more than 7 days. So the default is 10 days, which I think is quite a lot. If you have not taken a backup in more than 10 days, why are you taking an incremental backup? You should really be taking a full backup at that point, and also don't wait that long, please. Don't do that. But if for some reason you need to make this more or less, you can do that. We also have a new debugging tool called PG Wall Summary, which makes it possible to look at the contents of the wall summary files and see exactly what information is contained there. So again, you can tell that I'm very worried about bugs. I want to have tools to understand exactly what has happened in the case of any difficulty. So we have this new debugging tool here to help us with that. Now, once we have summarized the wall, how do we actually take an incremental backup? So the main thing to understand here is that we want to only copy the data which has changed since some previous backup. But which previous backup? You might think it's always going to be the last backup that we took, but that doesn't need to be the case. That's not required. And people sometimes want to do different things. So here is an example. Say on Sunday, we take a full backup. Then on Monday, we take an incremental backup. And it needs to contain all of the changes since Sunday, because that is the only previous backup that we have. But then what about when we take another incremental backup on Tuesday? Should the incremental backup that we take on Tuesday contain everything that has changed since Monday? Or should it contain everything which has changed since Sunday? Some people are going to want one thing. Some people are going to want the other thing. It's OK to want either one. Nobody is wrong here. This is an opinion question. So we need to be able to say, since which previous backup will be our reference backup, compared to which previous backup are we copying, what has changed. So in order to do that, you specify that you provide the backup manifest file from the previous backup. Every backup, by default, contains one of these backup manifest files. If you are using a newer version of Postgres, certainly you will have that in 17, but also the last couple of releases, we still had that. So here I show the examples from the previous slide in the form of PG-based backup commands that you can run. So first, at the first bullet point, I show how we can take a full backup. The argument to -d is the directory. So that first full backup is going into a directory, and the name of the directory is Sunday. Also here, because we are just testing, I have specified -c fast, which says that this backup should be taken with no delay. So if you are on a busy production system, maybe you don't want to use -c fast because it will put some load on your server that you may not want. But if you are just testing, you may want to use this because otherwise you may be sitting there and waiting. Now, then when we go to take the the incremental backup on Monday, we need to use the new -- incremental flag. And as an argument to that flag, we give the file name where the previous day's backup manifest, the previous backup's manifest is stored. So since we put the backup in the directory called Sunday, the backup manifest will be Sunday/backup manifest, and we're going to write our incremental backup into a directory called Monday. Then on Tuesday, we have two choices. We can either pass the backup manifest from Sunday again, as shown in the first command there, or in the second command, we can pass Monday's backup manifest, and then we'll have changes included in the backup compared to whichever manifest we specify. Now, what information do we actually get from the backup manifest? What is stored there that helps us? Well, remember, we are determining what has changed using the wall, using the write-ahead log. And the write-ahead log does not have any time, or at least our wall summary files do not have any times in them. So we do not know from the wall summary files what time any backup was taken. We only know the position within the wall, which we call LSN. And the backup manifest contains the LSN where the previous backup was taken. So by being given the backup manifest, we know the LSN where the reference backup began, and then we know that we need all the wall summary files since that write-ahead log position. So that is the main thing that we need from the backup manifest. But we also get a list of all the files that were included in the previous backup from the backup manifest. And initially, I thought maybe that wasn't required, but it turns out to be necessary in order to sort out some corner cases. If we have a file that has not changed at all between the start of the previous backup and the start of the current backup, actually there are two possibilities. One is that that file was there at the time the previous backup was taken, and still it's identical. And the other possibility is that file was not part of the previous backup at all, but it was created after the current backup started. If it was created between the start of one backup and the start of the current backup, then from the wall summary file, we would know that. We would know this file is created. But if it's created after the start of the backup, well, we have already read the wall summaries at that point, and it wasn't mentioned because it didn't happen yet. So in that case, the list of files from the backup manifest will let us do the correct thing. Now, it is nice to be able to take a backup, but it is really important to be able to restore a backup. So let's talk about how we can do that. Let's look at our same example that we have been using, Sunday, Monday, Tuesday. And here I will use the case where Tuesday's backup was taken compared to Monday. So where actually is our data? If we want to restore the database to the state that it had on Tuesday, where is our data? Well, whatever changed between Monday and Tuesday, that's in the Tuesday directory. The rest is not there. Whatever changed between Sunday and Monday, that's in the Monday directory. And every other thing is in the Sunday directory. So actually, we need to collect all of our data from those three directories and bring it all together into one place. So in order to do that, we use a new tool, also added as part of this incremental backup work, called PG Combined Backup. And we need to give it all of the directories where some of our data is in the correct order, starting with the oldest and going up to the newest. And then we say -O for output, and we provide the name of a result directory where our full backup is going to get written. So this will pull whatever data is required from each input directory, and it will write everything to the output directory. It will also do a lot of sanity checks because it wants to make sure that you have not done something wrong. And if you did do something wrong, it wants to tell you what you did wrong so that you will not think, Robert Haas is really dumb. But instead, you will know that you have made a mistake. So when we get this full backup, what can we do with it? Well, we can do with it any of the same things that we can do with any other full backup. But the really important thing here is recovery is still required. when you take any full backup using PG-based backup in PostgreSQL, database recovery needs to happen after that. And just because you used incremental backup doesn't mean that step is removed. Instead, an additional step is added. Everything that you would have to do anyway, you still have to do, only PG combined backup has to be done first. So you might need to create recovery.signal or standby.signal. You might need to set up primary con info. You might need to set up restore command. You might not need to do anything. It depends on whether you have write-ahead log files included in your backups. And it depends on whether you're trying to create a standby or do point-in-time recovery. Or it depends on the scenario, and I can't go into all the possible scenarios in this talk. But just remember, you don't get to skip any steps here. One thing that's kind of cool about this PG combined backup tool is that you can break up the operation into multiple steps. So before we saw PG combined backup Sunday, Monday, Tuesday, output to Tuesday full. But we could also PG combine backup Sunday, Monday, and write the result to Monday full. And then we could do PG combine backup Monday full and Tuesday, and write the output to Tuesday full. Now, I think somebody in this room is thinking, why would I ever want to do such a thing? Because in the way that we actually showed it on the previous slides, we only had to write one output directory. But if we break it up into two steps like this, we will have to write two output directories. So actually, in this example, the cost is doubled, which is not very appealing, right? But actually, this opens up a very interesting use case, which is that potentially full backups are not required. Let's think about this. Let's suppose I say, I don't like taking full backups. It's no fun. I'm only going to take an incremental backups. So every day, I will take an incremental backup using the previous day's backup as the reference backup. So every day I will get a backup that contains the changes between yesterday and today. What problem am I going to have? Well, actually, I will have only one problem, which is that eventually I will have to keep too many backups, right? And if I need to do a restore, all of those backups are going to need to be passed to PG combined backup. So if I take a full backup one day, and then every day after that for a year, I take an incremental backup based on the previous day, and then I need to do a restore of my latest backup, I need to pass 365 backups on the command line to PG combined backup. That probably isn't going to work well. I probably don't want to store all of those backups. I probably don't want to manage all of those backups and make sure there's no corruption and all those things. I don't want to have that many backups floating around. And you could use this trick with PG combined backup in order to avoid this. Because you could combine your very oldest backup, let's say it's Sunday, with the incremental backup that directly follows it, Monday in this case, and you get Monday full. Then you remove the original Sunday and Monday, and you move Monday full's backup in place of your original Monday backup. And now you've shortened the chain of backups by one. If later I need to restore to Wednesday, then instead of saying PG combined backup Sunday, Monday, Tuesday, Wednesday, output to Wednesday full, I can just say PG combined backup Monday, Tuesday, Wednesday, output to Wednesday full, because actually I turned the incremental backup that I had in the Monday directory into a full backup. And now not only do I have that full backup, but I can use that as the basis for restoring the backups that come later. Now, of course, you should only do this if you trust that this feature has no bugs. So maybe wait a year or two before you do this, just to give us some time and to get anything fixed that might be wrong. Or maybe try it now, but maybe not on your most critical system. I think I would really like to get some feedback from people on their experience with this, how well it works, did they have any problems. But obviously, there is some risk here if you stop taking full backups. Question? Yes, the PG combined backup requires that the backups be in the exactly correct order. You have to start with the full backup and then do the incremental backups from oldest to newest. You also can't include any, you can't just put all your backups in there. It wants you to give it exactly what is required and not anything more or less. And if you just throw everything at it, it will say, you are not doing it right. It will give you some error. So unless you have some tool, we'll talk about that later, but unless you have some tool, you yourself have to keep track of which incremental backups depend on which full backups, what directories do I need to keep around, what do I need to have available in order to do a restore, and which things am I going to combine. Because this is only a system for taking the incremental backups. It is not a system for sorting out what you have where. And it's intentionally very picky because I want to make sure that we can catch usage mistakes. I added a --debug option to PG combined backup. And then I found that it actually wasn't printing enough information for me to find the problems. So I added a lot more information that gets printed out when you use this option. So if you try out this feature and something unexpected happens and your data seems to be corrupted, and you ask me, how can I find the problem? I'm going to say, can I please see the output with --debug? Because then probably I will be able to sort out exactly where things have gone wrong. So now I'm coming to the end of the talk. I'm actually not quite sure how I'm doing on time, but I think I'm about in the right place. I'll just talk a little bit about future directions here, because whenever you do any work like this, some big project, people always say, well, what's the next thing? What is left to be done? So one thing that needs to happen is the tools, as I was just mentioning a moment ago in response to the gentleman's question, need to be extended to support this. Because it's going to have an impact on retention policies in particular. If you say I want to retain all my backups for 1 month, right now that's all you need to do. But with this feature, that won't work, because then you might throw away the full backup. Well, you still have the incremental backup. But you cannot use that incremental backup for anything without having the full backup. So the tool is going to need to understand the relationships between the backups. And currently they don't, because this feature is not released yet and didn't exist until very recently. So that part of the work, I think, is probably going to be mostly outside of PostgreSQL itself. In the tools. Sometimes people say, maybe we should have tools like this in core. Maybe, but actually this kind of stuff I think is quite good to do outside of core. It lets different people take different approaches. Not everybody has to like the same tool or do all of the things in the same way. I think this backup management stuff can be effectively done outside of core, and that's pretty nice, as opposed to something like incremental backup, which is very deep into the guts of everything. And I think that fits better into PostgreSQL itself. Another thing that is sort of an obvious gap here is that PG combined backup has a number of different scenarios that we could potentially support, but right now we don't support. So for example, it supports directory format backups, but not tar format backups. And if you're storing your backups in the cloud or someplace where you don't want to have a million little files, you're very likely to be using tar format backups. So this limitation could require you to do extra steps. You might need to download your tar files and then extract them to produce a directory format backup, and then after that run PG combined backup. So it would be nicer if PG combined backup could work directly on your tar files. And it would be even nicer still if it could work on your tar files while they are still in the cloud, so that you don't first have to download them and then extract them. But I did want to get the project done before the release shipped, so these features are not included, and maybe we can add them in a future release. All right, that is it for the main presentation, but I can take questions in whatever time we have.
Is it possible to combine only incremental backups?
That is a great question. Is it possible to combine only incremental backups? That is another thing that PG Combined Backup could do, but right now it doesn't know how. And the reason is because in order to do that, it would need to be able to take two incremental files and merge them together and write out another incremental file. And right now, it only knows how to merge full files with incremental files and write out full files. So the code just isn't there. So it would be a good thing to have, but code's not written.
Thank you. So regarding the debug option, so can we use this to validate the backup's validity? Is the backup piece is valid?
So the debug option is not going to give you any errors or warnings or anything like that. We do have PG Verify Backup, which can be used in some scenarios to help with some things. But debugging is different from verification. So nobody should use the dash debug option and say, oh, everything is fine because I didn't get an error with debug. That's not what it does. What it does is it prints out a very detailed description of what it did at every single step. So if you already know that it did something wrong, you can then go and look through all of that output to try to find out why did that thing happen rather than something else. But it's not going to be like if you use debug, then suddenly you'll find problems that otherwise wouldn't have been discovered. All of the error checks in PG Combined Backup are enabled at all times. So if it detects a problem, it's always going to give you that error. Adding dash debug won't help with that. The only thing it will do is print out all the details of what is happening at each step so that somebody can try to figure out if something went wrong, what exactly caused it to go wrong. Yes.
So would that give us the information of validating that if the backup is going fine? I would expect that when the backup is running, or when the PG Combined Backup is running, it should show me a print on the screen that, okay, this step went fine, or this or the in progress, that this is going well inside the backup, or this is where it failed, or.
Yeah, so the difficulty with this is that validation means different things to different people, right? What does it mean to validate a backup? So in the case of the PG Verify Backup utility, what it's verifying is that the backup we have now is the same as what the server thinks it sent. So PG Verify Backup can help you find, for example, corruption that occurs on disk, right? But it doesn't tell you whether the server intended to send you the right stuff originally, right? And PG Combined Backup can't really tell you that either. It will tell you about things like, there's some file I need to read and actually I can't open it. It will tell you, I have an incremental file here, but the checksum for that file does not pass. It will tell you things like you are trying to combine backups from two completely different database clusters and those don't match. All of those things it will tell you about, but it doesn't necessarily have the ability to detect, like if it produces an output file, how do we know that that output file is correct? Well, that depends on whether the input files are correct, and that may be information that we just don't have, right? It has to use the information that it's given, so it can't really detect all of the errors that we would like to be able to detect. So I'm interested in finding out ideas from people, maybe not right this minute, but what we can talk later after the presentation, like how could we do better error checking here? I've really put a lot of effort into the error checking to detect as many problems as I can. But at some level, if somebody says, here is this block and it goes at this space, how are you supposed to know if that's actually the correct block to put in that place? You have to trust that what the server sent you was the right thing. And it should be. You shouldn't really have a problem there, but obviously all kinds of crazy situations can happen.
How far would be the expanse of the backup utility support when it comes to Postgres versions? So suppose you release this in PG18 as a stable one.
You can only use incremental backup with a new release of PostgreSQL after this feature. You can't use it to take incremental backups against older versions.
Yeah, but say it got released in 18 and I'm say going for a few years down the line, maybe it's say PG22. So at that
I don't have any expectation that an incremental backup is going to be able to cross releases, right?
Okay,
Like when you upgrade to a new major release, you're going to have to go through PG upgrade or a dump and reload or a logical replication switchover and stuff like that. At that point, you're going to need to start over with a new full backup. Because among other there's a lot of problems with making that work. One problem is the write-ahead log format changes between major versions. And since this is based on summarizing that format, it's inherently version specific. Can we take a few questions from the back, perhaps? Please either wait for the mic or speak a lot more loudly.
What's the time that combined backup takes? Because that has a direct impact on the restore times that customers will see.
Of course, the time that is required for PG combined backup is going to depend on your hardware. Now, I did make an effort to make it smart. So let's say you have a full backup and it's 1 terabyte, and you have an incremental backup and it's 500 gigabytes, half a terabyte. Now, you run PG combined backup, and the major thing that determines the time is going to be how much data do we have to read and write. And what PG combined backup actually does is it builds a map of where each block needs to come from for each file, and then it reads only those blocks. So it's not going to read the whole 1 gigabyte and then the whole half gigabyte and then write everything out, right? It's going to read only the parts from each, only the blocks from each backup that are actually required. So the total amount of I/O should be more similar to the size of the output than the size of the sum of the inputs. So I think it will be pretty fast, but it's a lot of I/O. If you're using this on a big database, you're writing out a big directory, how fast is your disk, you know? Okay, I'm told that is all the time that we have for questions. So thank you very much. I can take individual questions afterward, but we are concluded on this session. Thanks.